Dear students, today we shall discuss Poisson integral formula, Cauchy's inequality, and then few examples based on Cauchy integral formula and Cauchy integral formula for higher order derivatives. So let's start with Poisson integral formula. If fz is analytic in the region mod z less than or equal to rho, fz is analytic in this region, and r is any number so that r lies between 0 and rho, then value of the function at a point a where a mod of a is equal to small r, so a is r e to the power I theta, so f at e r e to the power I theta is given by 1 upon 2 pi 0 to 2 by r square minus r square f of r e to the power I phi upon r square minus 2 rr cos theta minus phi plus r square d phi, where z is equal to r e to the power I theta is any point of the domain mod z less than rho. Suppose that gamma denote this circle mod of z is equal to r, such that capital R lies between small r and rho. Now since fz is analytic within and on the circle gamma, and a is equal to r e to the power I theta is any point within the circle, therefore by Cauchy's integral formula we have f of a is equal to 1 upon 2 pi I integral over gamma fz dz upon z minus a. Now the inverse point of a with respect to the circle gamma is given by r square upon a bar, and this point r square upon a bar will lie outside the circle gamma. So therefore the function fz upon z minus r square upon a square a bar will be analytic within and on gamma, because r square upon a bar lies outside gamma, so therefore this function is analytic within and on gamma. So therefore by Cauchy's theorem integral of this will be equal to 0. So 0 is equal to integral over gamma fz upon z minus r square upon a bar dz. Now subtract equation 2 from 1. We have fa is equal to 1 upon 2 pi I integral over gamma fz upon z minus a minus fz upon z minus r square upon a bar dz, which can be written as 1 upon 2 pi I, take LCM as z minus a into z minus r square upon a bar and fz common, and then in the numerator we have a minus r square upon a bar, which can be written as 1 upon 2 pi I integral over gamma a bar minus r square upon z minus a into z a bar minus r square fz dz. Now because mod of a is equal to r, so therefore a is equal to r e to the power I theta, so a bar is r e to the power minus I theta, and mod of z is r, it's given to us, so therefore z is equal to r into e to the power I phi, so dz is equal to I times r e to the power I phi d phi. Now substitute the values in this equation. So in place of a we put r e to the power I theta, so f of r e to the power I theta is equal to 1 upon 2 pi I, a into a bar is small r square minus capital R square, f of z is f of r e to the power I phi, dz is I r e to the power I phi d phi upon z minus a is r e to the power I phi minus r e to the power I theta, z a bar is r e to the power minus I theta e to the power I phi minus r square d phi. I gets cancelled, so we have f of r e to the power I theta is equal to 1 upon 2 pi 0 to 2 pi, take minus sign common from numerator and denominator, so we have r square minus r square f of r e to the power I phi r e to the power I phi d phi divided by r e to the power I phi minus r e to the power I theta multiplied by r square minus r e to the power I phi into r e to the power minus I theta. Now let's simplify the denominator. So denominator is r e to the power I phi minus r e to the power I theta multiplied by r square minus r e to the power I phi into r e to the power minus I theta. Take e to the power I phi common from this bracket and r common from this bracket. So we have e to the power I phi into capital R minus r e to the power I times theta minus phi multiplied by r into r minus small r e to the power minus I times theta minus phi, which can be written as r e to the power I phi, and now you multiply these two, we have capital R square plus r square minus r into r e to the power I times theta minus phi plus e to the power minus I times theta minus phi. And now you know that cos theta is e to the power I theta plus e to the power minus I theta upon 2. So therefore this term is 2 times cos of theta minus phi. So therefore this thing is equal to r e to the power I phi r square plus r square minus r 2rr into cos theta minus phi. So substitute in this equation in the denominator. So r e to the power I phi will get cancelled. So therefore f of r e to the power I theta is 1 upon 2 pi integral 0 to 2 pi r square minus r square f r e to the power I phi divided by r square minus 2rr cos theta minus phi plus r square d phi. So this is known as Poisson's integral formula. Now let's take the proof of Cauchy's inequality. The proof is very simple. What is the state? Let fz be analytic in a domain D if gamma be the circle defined by mod of z minus z naught is equal to r, which lies entirely inside D, and function fz is bounded, that is mod of fz is less than or equal to m on gamma. Then mod of fn z naught means value of nth derivative of function at z naught is less than or equal to factorial n into m divided by r to the power n. So proof is based on this formula which we have proved earlier. Fn z naught is factorial n upon 2 pi I integral over gamma fz upon z minus z naught raised to the power n plus 1 dz. Take modulus on both sides. Now this is less than or equal to factorial n upon 2 pi, modulus of I is 1, then integral over gamma mod fz mod dz mod of z minus z naught to the power n plus 1, which is less than or equal to. Now mod of fz is less than or equal to m, it's given to us. What is mod of z minus z naught? Mod z minus z naught is r, so r to the power n plus 1 integral over gamma mod of dz. Now what is integral over gamma mod dz? This is circumference of the circle of radius r. So this is 2 pi r. So therefore modulus of fn z naught is less than or equal to factorial m into m divided by r to the power n. Now let's take few examples. First example, evaluate integral over c dz upon z minus 1 where mod of z is equal to 2. Now what is mod z is equal to 2 denote? Mod z is equal to 2 is a circle with center at the origin and radius 2. Now this function dz upon z minus 1, if you put denominator 0, we have z is equal to 1 and z is equal to 1 lies inside the circle mod z is equal to 2. Now from this formula we have, if you cross multiply, we have integral over c fz dz upon z minus a is 2 pi I into f of a. So therefore since a is equal to 1 lies inside the contour c mod z is equal to 2, so therefore we take f of z is equal to 1. So we have integral over c 1 upon z minus 1 dz is equal to 2 pi I into f at 1. Now what is f at 1? Because f of z is 1, constant function, therefore f of 1 is also 1. So therefore value of this integral is 2 pi I. Next example, evaluate integral over mod z is equal to 2 e to the power z plus z square upon z minus 1 dz. Now you can see that this function is analytic within and on the circle mod z is equal to 2, and singularity of this whole function is z is equal to 1, which lies inside mod z is equal to 2. So therefore by Cauchy's integral formula, integral over mod z is equal to 2 e to the power z plus z square upon z minus 1 dz is equal to 2 pi I into f at 1. Now f at 1 is, from this equation, f at 1 is e to the power 1 plus 1 square. So this is equal to 2 pi I e to the power 1 plus 1 square, which is 2 pi I into e plus 1. Third example. Using Cauchy's integral formula, calculate the following integral. Integral over c dz upon z into z plus pi I, where c is the contour circle mod z plus 3i is equal to 1. Now because mod of z plus 3i is equal to 1, this can be written as mod of z minus 3i is equal to 1. So this is a circle with center at 0, minus 3 and radius 1. Now if you take denominator 0, so we have z is equal to 0 or z is equal to minus pi I. Z is equal to 0 lies outside this circle, and z is equal to minus pi I lies inside this circle. So therefore we take f of z is equal to 1 upon z, and so we have integral over c dz upon z into z plus pi I is equal to integral over c fz upon z minus pi I dz. So we take fz is equal to 1 upon z. So by Cauchy's integral formula, this is 2 pi I into f at minus pi I. Now because f of z is 1 upon z, so f of minus pi I is minus 1 upon pi I, which is equal to minus 2. Okay, let's take one more example. Using Cauchy's integral formula, evaluate integral over c e to the power 2z upon z plus 1 to the power 4 dz, where c is the circle mod z is equal to 3. Now we know the formula for n derivative fn a is equal to factorial n upon 2 pi I integral over c of z upon z minus a to the power n plus 1 dz. So therefore integral over c of z upon z minus a to the power n plus 1 dz is 2 pi I upon factorial n into fn a. Now if you compare these two, what is fz? Fz is e to the power 2z. What is a? A is minus 1, and n plus 1 is 4, so therefore n is equal to 3. So therefore integral over c e to the power 2z upon z plus 1 to the power 4 dz is equal to 2 pi I upon factorial 3, third derivative of fz at minus 1. Now f of z is e to the power 2z. So f dash is twice e to the power 2z, f double dash is 4 e to the power 2z, f triple dash is 8 e to the power 2z. So therefore third derivative of fz at minus 1 is given by 8 into e to the power minus 2, that is 8 upon e square. So put this value here. So we have e to the power integral over c e to the power 2z upon z plus 4 d to the power 4 dz is equal to 2 pi I upon 6 into 8 upon e square, which is 8 pi I upon 3e square. Thank you so much.